There is a house standing in Boston that was built in 1875. It has no air conditioner, it has no ceiling fans. Yet, on a 95-degree summer day, the interior stays a comfortable 72 degrees Fahrenheit. There is a piece of Victorian engineering built into its walls that modern American homes have completely abandoned. Let's dive in. Right now, the average American household spends between $250 and $500 a month on summer electricity, and roughly 70% of that bill goes to air conditioning. That is over $3,000 a year sent to a utility company for the privilege of keeping your home livable during 3 months of heat. And if you have looked into replacing your central air system recently, you already know the alternatives are not cheap either. A basic mid-tier central AC unit runs between $5,500 and $9,000 after installation. High-efficiency heat pump systems push past $18,000. Ductwork replacement adds another $3,000 to $7,000. The compressors alone, the ones every HVAC contractor pushes as the heart of the system, cost between $1,800 and $3,500 to replace when they fail. And here's the part nobody puts in the sales brochure. Modern residential air conditioning systems are rated for roughly 12 to 15 years of service life. When they degrade past a certain point, you replace them at full retail. Again, that is not climate control. That is a subscription plan bolted to your foundation. And the modern American construction industry itself is not exactly honest about the reason. Between 1850 and 1910, American home builders produced tens of thousands of houses that regulated their own interior temperature without any mechanical assistance. Those homes are still standing today. Many are still cooling themselves through New England, Mid-Atlantic, and Midwestern summers, using the same principles their original architects specified 150 years ago. The engineering that made those houses work was quietly abandoned after World War II, replaced by thin-walled, poorly insulated, mechanically dependent construction that requires an electric compressor running 12 hours a day to remain habitable. You are paying more than ever for houses that perform worse than the ones your great-great-grandparents built with hand tools. And when you see what actually made those older houses work, you will understand why no major residential builder has advertised these techniques in over 70 years. The physics beneath every Victorian home has been regulating temperature since before your grandfather was born. It does not degrade. It does not require refrigerant refills, and it does not care whether a heat wave hits in July or a cold snap hits in January. But the real question is not whether Victorian passive cooling works. The engineering data on that was settled 150 years ago. The real question is what happens when you understand the specific combination of thermal mass, Castrian geometry, and natural convection that made those homes self-regulating. And that is where this architecture stops being nostalgia and starts being a threat to a $180 billion HVAC industry. But to see why, you need to understand the mechanism. Because once you see how simple the thermodynamics actually is, you will never look at a modern tract home the same way again. Victorian passive cooling was not a single feature. That name sounds like a specific technology, but the principle was a coordinated system of 3 physical properties working together: thermal mass, convection, and precisely engineered airflow paths. Each one is a physical principle you already know. If you have ever walked into an old stone church on a hot afternoon and felt the sudden drop in temperature, you have experienced the first property. Dense materials absorb heat slowly and release it slowly. That is thermal mass. If you have ever watched smoke rise from a chimney, you have observed the second property. Warm air is less dense than cool air and rises. That is convection. If you have ever felt a draft in a hallway as air moved from an open window through a house to another open door, you have felt the third property. Air flows from high pressure to low pressure through the shortest available path, that is engineered airflow. Victorian architects combined these 3 principles into a single self-regulating system. Solid brick or stone walls, typically 12 to 18 inches thick, absorbed the heat of the day and released it slowly at night. Tall ceilings, usually 10 to 12 feet in main rooms, allowed hot air to rise above the level where people actually lived. Cupolas and roof monitors on top of the house created a chimney effect, pulling hot air up and out through vents at the highest point of the roof. Cast-iron radiators and cast-iron ductwork provided controlled convection paths that could be adjusted seasonally. Deep porches and overhanging eaves blocked direct summer sun while allowing lower-angle winter sun to enter and warm interior surfaces. Every element served a specific thermodynamic function. Every element was calculated, and every element still works today in the homes that were built to those standards. Here is what happens inside a well-designed Victorian home on a 95-degree summer afternoon. The exterior wall surface absorbs solar radiation and rises to perhaps 120 degrees Fahrenheit. That heat then begins to conduct through the 16 inches of brick and plaster. Because brick has a thermal conductivity roughly 1/10 that of modern wood frame construction, the heat moves slowly. It takes approximately 10 to 12 hours for peak exterior heat to reach the interior surface of the wall. By the time that heat arrives inside the room, it is evening. The outside air has cooled. Windows open at the top of the house, in the cupola or roof monitor exhaust the heated interior air upward through natural convection. Cool evening air draws in through lower windows. The house essentially breathes overnight, releasing the day's accumulated heat and drawing in the cool night air. By morning, the interior is comfortably cool again, and the cycle repeats. A single well-designed Victorian home in Boston, Philadelphia, Chicago, or St. Louis. Built with solid masonry walls between 12 and 18 inches thick, a proper cupola or roof monitor, and tall interior ceilings. Will maintain interior temperatures 15 to 25 degrees cooler than exterior peak temperature without any mechanical cooling. That is not enough to make a desert home comfortable in July. But here is where the engineering starts. In climates where daily temperature swings exceed 15 degrees, meaning most of the temperate and continental United States, the thermal mass effect alone can carry a home through the entire summer without air conditioning. In the driest parts of the country, combining these principles with evaporative techniques, using shallow rooftop water pans or damp wool hangings and open windows, extends the effect into the deserts of the Southwest. And none of it requires a single kilowatt of electricity or a single ounce of refrigerant. That fact alone tells you why you have never been told about it by a modern builder. And unlike a modern compressor-based air conditioner, a Victorian passive cooling system does not fail in a power outage. It does not require annual service. It does not need refrigerant recharge. It has no moving parts. In a region with normal seasonal temperature swings, that means your cooling system becomes something you actually own, rather than something you rent from a utility company. Now, there is a second reason this architecture was quietly buried, and most people have never heard the full story. In 1902, an American engineer named Willis Carrier installed the first electrically powered air conditioning system in a Brooklyn printing plant. Over the following decades, Carrier and his imitators refined the vapor compression cycle into a commercially viable technology. By 1928, air conditioning was being installed in luxury movie theaters. By 1946, the first residential window units were being sold in American homes. But the real transformation came in the post-war building boom. Between 1945 and 1965, the United States built approximately 20 million new suburban tract homes. Those homes were designed to be built fast, cheap, and profitable. Solid masonry walls were slow and expensive. Tall ceilings wasted square footage. Cupolas required skilled carpenters. Everything the Victorian architects had spent 60 years perfecting was eliminated from the specification. Instead, the post-war home was framed in inexpensive lumber, sheathed in thin plywood, and wrapped in the minimum amount of insulation required by code. The interior ceilings dropped to 8 feet. The exterior walls thinned to 4 inches of stud framing. The cupolas disappeared entirely. The overhanging eaves shrank 2 inches instead of feet. Every one of the thermodynamic principles the Victorians had used was quietly removed from residential construction, and then into the resulting thermally unstable structure. Builders installed a mechanical air conditioner as the only means of making the house habitable during summer. The customer now needed an HVAC system to live comfortably in a home that generations earlier would have cooled itself. The utility company got a permanent recurring customer. The HVAC industry got a $180 billion annual market. And the passive cooling knowledge that made all of it unnecessary was written out of the architecture curriculum. But if you think Victorian passive cooling was invented in the 1800s, you are off by centuries. Roman architects in the 1st century BCE built villas with hypocaust flooring systems that regulated interior temperature. year-round through underground airflow channels. Roman writer Vitruvius, in his 10-volume treatise De Architectura, dedicated multiple chapters to proper building orientation, wall thickness, and window placement for climate control. Medieval European monasteries incorporated thick stone walls, north-facing cool rooms called celleria for food storage, and precise window placement to manage light and airflow. Islamic architects in Andalusia developed courtyards, pools, and shading patios that produced comfortable interior conditions in the hot Spanish summer, without any mechanical assistance. Every literate architectural culture in temperate and hot climates had detailed knowledge of passive climate control long before electricity existed. By the 1600s, English country houses were being built with a specific combination of thick walls, tall ceilings, and roof-level ventilation that the Victorians would later refine into a documented science. Thomas Jefferson's Monticello, designed and built between 1768 and 1809, incorporated a passive cooling design so effective that modern researchers at the University of Virginia have measured its performance and confirmed interior temperatures 20 degrees below exterior peak on summer days. Jefferson used the same principles that Victorian architects would systematize half a century later. Thick brick walls, tall ceilings, a rooftop dome acting as a thermal chimney, deep porticos blocking direct sun. Every element served a specific thermodynamic purpose. But the Romans and Andalusians were not even close to the first civilizations to control interior climate through building physics alone. Archaeological evidence from Neolithic sites across the Fertile Crescent, dating to 6000 BCE, shows deliberate use of thick mud brick walls and semi-underground rooms for temperature regulation. Ancient Egyptian tomb chambers were engineered with precise wall thickness and internal airflow paths to maintain stable conditions across thousands of years of desert temperature swings. This is not fringe archaeology. It is one of the oldest continuous engineering traditions in human history. You can restore Victorian passive cooling principles in your own home today using techniques any competent contractor can implement. And yet, almost none of this appears in a modern American residential construction conversation. Now, fast forward to the modern research that has finally quantified what Victorian architects already knew. In June of 2026, researchers at Loughborough University in England published a landmark study examining Victorian buildings during the recent European heat waves. Their measurements confirmed that houses built between 1840 and 1910 with proper solid masonry walls, tall ceilings, and functional convection paths remained 15 to 20 degrees Fahrenheit cooler than adjacent modern buildings during peak heat conditions. The study, published through the Loughborough School of Architecture, Building, and Civil Engineering, identified 5 specific design features that made Victorian homes thermally superior. Solid, load-bearing masonry providing thermal mass, correctly proportioned window-to-wall ratios that admitted daylight without excessive solar gain. Tall interior ceilings that stratified hot air above the occupied zone. Roof-level ventilation, exhausting hot air through natural buoyancy. And deep external shading via eaves, porches, and window awnings. Separately, a 2024 peer-reviewed study published in the journal iScience by researchers Halapaska and colleagues documented 19th-century thermosiphon ventilation systems and confirmed their continued relevance for modern low-carbon architecture. The paper appears in the Science Direct database and is freely accessible. That research, conducted at the intersection of architectural history and modern building science, has shown that the Victorian approach to convection cooling produces measurable comfort. Improvements even in contemporary construction when the principles are properly applied. And in the United States, historic preservation organizations, including the National Trust for Historic Preservation and the Association for Preservation Technology, have published dozens of technical briefs on Victorian passive cooling. Every one of these documents is publicly available. Every one is free to download. And every one contains engineering data that would allow a homeowner to understand, restore, or replicate the original cooling design of a period home. Every one of these examples is documented, published, and verifiable. And yet the total number of American residential building permits issued last year for new construction incorporating Victorian passive cooling principles remains vanishingly small. So if this architecture predates modern air conditioning by a century and was confirmed by Loughborough University in 2026, why isn't it in a single suburban builder's catalog? Because the system was never designed to accommodate a home that does not need mechanical cooling. The modern American residential construction market runs on standardized platforms, engineered lumber packages, code-mandated HVAC systems, and utility-integrated infrastructure. Victorian passive cooling is not on any of those specification sheets. Not because it fails, because no major HVAC manufacturer can sell a compressor to a house that does not need one. There is no distribution channel for solid masonry walls of Victorian proportions. There is no volume production for cupolas and roof monitors. There is no financing package for construction that takes 6 months of skilled labor instead of 6 weeks of framing. And without an HVAC system installed, there is no annual service contract, no filter replacement business, no refrigerant recharge revenue, and no compressor replacement cycle every 12 to 15 years. This is not a ban in the legal sense. It is something more effective than a ban. It is structural invisibility. The American residential HVAC market generates over $180 billion a year in revenue when you combine equipment, sales, installation, labor, ongoing service contracts, refrigerant sales, and utility electricity revenue tied to cooling loads. That revenue depends on homes designed to require mechanical cooling. Every dollar that flows through that system passes through equipment and infrastructure that someone owns, maintains, and invoices for. A well-built Victorian home generates no compressor sale. It requires no annual maintenance visit. It creates no refrigerant recharge revenue. It draws no summer electricity load for cooling. From the perspective of the modern HVAC economy, a properly designed passive cooling home is not a competitor. It is a non-customer. It does not fit into the financial architecture, and therefore, it does not exist within the regulatory architecture. No one conspired to suppress it. The frameworks that govern American residential construction were simply written for products that scale. Homes that can be built in 6 weeks by low-skilled crews using standardized components financed through approved lending structures. A house built with solid masonry walls and calculated convection paths does not clear a single one of those gates, and so it vanishes. Not suppressed, just never sold. Now, if you are thinking Victorian passive cooling sounds too expensive or too complex to matter in your life, stop and consider what you actually need to make a home comfortable through summer. You need to slow the transfer of heat from outside to inside. You need to store excess heat during the day and release it at night. You need a path for hot interior air to exit and cool exterior air to enter. You need shade on your exterior walls during peak sun hours. Every one of those requirements is met by principles a competent contractor can incorporate into either new construction or the retrofit of an existing home. None of them require a $12,000 central air conditioning system. All of them can be served by materials and techniques that were standard practice for centuries. If you want to start reducing your cooling energy costs today, we put together a full manual that covers everything in this video and more. The link is in the description below. Here is how the retrofit works. You have 3 practical paths depending on your existing home. First, if you already own a period home built before 1930, your house likely still contains most of the original Victorian passive cooling design elements. The exterior masonry is probably intact. The tall ceilings are probably preserved. The cupola or roof monitor may still exist, but may have been sealed shut sometime in the 20th century. Have a competent restoration contractor evaluate whether your original convection paths can be reopened. Restoring a working cupola vent typically costs between $1,500 and $4,000 and can dramatically reduce summer cooling needs. Second, if you own a modern home and want to add thermal mass without rebuilding, focus on the interior. A properly designed interior masonry wall on the south or west side of your main living area. Whether brick veneer over structural framing or a solid concrete block partition adds significant thermal mass. Costs between $6,000 and $15,000 for a substantial installation. That thermal mass moderates interior temperature swings and reduces peak cooling load significantly. Third, for anyone building new construction, work with an architect familiar with passive design principles. Specify solid masonry, exterior walls, or insulated concrete forms with a masonry interior finish. Specify 10 to 12-foot ceilings in main living spaces. Specify operable transom windows and, if possible, a roof monitor or cupola with automatic damper controls. The construction cost premium ranges from 8 to 15% above conventional light frame construction, but the operating cost savings over the lifetime of the home typically recoup that premium within 15 years. And the home continues to operate at zero mechanical cooling cost thereafter. Total cost to restore functional passive cooling in an existing period home comes in between $2,000 and $8,000 in labor and materials. Compare that to $150,000 in lifetime HVAC costs across a 40-year period, including equipment replacement cycles, service contracts, refrigerant recharges, and electricity for summer cooling. That is not a savings. That is a different economic universe. One critical warning: do not attempt structural modifications to a historic home without qualified professional guidance. Cutting into original masonry, opening sealed cupolas, or modifying roof structures on a period home can cause significant damage if done improperly. Hire a preservation contractor experienced with Victorian architecture. Consult with your state historic preservation office if you own a listed building. There are real limits, and you should know them. Passive cooling works best in climates with substantial daily temperature swings, meaning the temperate and continental United States, most of Europe, and moderate desert climates. In persistently hot and humid tropical climates, thermal mass alone is insufficient because nighttime temperatures do not drop enough to purge accumulated daytime heat. Those climates require supplementary evaporative cooling, dehumidification, or in some cases, minimal mechanical assistance. Passive cooling is also less effective in very small houses without adequate wall mass or vertical stack height. The technique scales best to homes of 1,500 square feet or larger with 2 or more stories. For small single-story dwellings in humid climates, expect passive cooling to reduce but not eliminate mechanical cooling loads. The Victorian passive cooling system is a 150-year-old answer to a question the modern HVAC industry was never designed to ask. It does not replace all aspects of modern climate control in every climate, but for the cost of restoring original architectural features or specifying them in new construction, it gives you a home that regulates its own temperature through thermodynamic principles. The Romans documented, the Victorians perfected, and Loughborough University confirmed in 2026. Using the same physics that has kept old brick and stone houses comfortable for centuries before electricity existed, a lot of what this channel covers was nearly lost. Not because it stopped working, but because the system was never designed to accommodate architecture that does not generate a monthly invoice. If discovering the lost science of self-regulating homes matters to you, subscribing and sharing is the simplest way to make sure this kind of knowledge keeps being found. If you had a 150-year-old Victorian house with a sealed cupola and thick brick walls, would you invest $3,000 to restore its original passive cooling design? Or would you still hire an HVAC contractor and pay $12,000 for a central air system that will need replacement in 15 years? I would genuinely like to know. Drop it in the comments.